Hello friends, once again I welcome you to my channel. In this video we will see instruction set. We'll continue our discussion on instruction set. Last video we have seen data movement instructions. Next category is data manipulation instruction. Under that three subheadings are there. One is arithmetic instructions, then next is logical and bit manipulation instructions, and the third one is your rotate instructions and all that we will see one after another. So first I'm coming to your arithmetic instructions. So most of the instructions already we have come across. These are very simple. First one is increment. Increment means what? We are increasing the value of my operand by 1. Decrement, we are decreasing by 1. Add means performing the addition. Subtraction also you understand. Multiply you understand. Division also you understand. Another one, two more are there. Add with carry, subtraction with borrow. Whenever we are doing addition, our carry flag value will be 1. That means along with the two operands, we will assume that there is one carry from the previous addition, right? Or carry is on whenever we are doing the addition operation. If we are doing multi-byte addition, then after one byte addition, if it is generating carry, that will be carry over to the next byte addition also. Or suppose if I'm adding only two numbers and it is with carry, that means previously carry flag was 1. That also we will consider whenever doing the addition process. And the same thing is applicable for subtraction operation. There it will be termed as borrow. Whenever I am doing a subtraction operation, initially I'll assume that there is a borrow, right? So with this we can do this arithmetic operations. These are simple arithmetic operations. These are the various mnemonics. So already we have come across many of them. The next category is your logical and bit manipulation instructions. So we'll start one after another. This clear is for clearing the contents of a register, making the contents equal to 0. Complement means taking the ones complement. And or jot logical operations we know. Where at all we need to apply, that I am going to discuss. These also I am coming to them. So first coming to your AND operation. AND operation logic level is already known to us, right? AND operation is used for doing the AND operation between two operands, right? And the logic says that if the bit values are 1 0 1, sorry, if it is 0 0 0 1 1 0 or 1 1, then the answer for all of them is what? 0, right? And in the last case only it will be 1, right? So see, what we can say that we can use AND instruction to reset the value of a particular bit position in a register. Suppose one register contents are given to you, right? One register contents are given to you. You need to reset the bit position value at a particular position. That is asked to do, right? We need to do that. Say this bit position value we need to reset to 0. And all other bits, I don't know what is their value. I don't know any one of their value, right? All of them are not known to me, so all are don't care for me. I do not know any one of their value, right? Simply I know that it is a register content. What I am supposed to do is this bit I need to make 0 and all other bits whatever they were there previously, I'm not going to change them. They were whatever they were, they will remain as it is, right? Then we can apply AND operation. And the AND operation, what will be the operand? Whenever I am doing the AND operation of this register content with some operand, so that my result will become this, then this logic level will help us. What we have seen, something, I don't know what is this something, whether it is 0 or 1 is not known to me. With something, if I AND 1, what is the result? That result is always that something. Means if it was 0, it will be 0. If it was 1, then the result will be 1. So wherever I don't want to change, at those positions I will AND with 1 1. See, I'll AND with 1 1. And wherever I want to change, that means I want to make 0, there I will AND with 0. Then see, your result will be at these particular positions, the bit values will be as that of their previous values in the register. And this particular position, whichever is asked to change to 0, that is already changed to 0. So see, whenever you are changing a particular bit position, you need to keep in mind all other remaining bits we should not change, right? With this in mind, we need to do it. So see, whatever I have explained, now I will do it formally with an example, as well as example is already done. And then what is the corresponding instruction I should write, that I am going to explain next. So AND instruction is used to basically reset some specific bit position. You can do AND for anything, but particularly we can use in this particular circumstance. It is used to reset some specific bit position in a register or wherever, keeping all other bits intact. That means other bits I should not change, right? Then let's say this is one register R1. The contents are given like this. And whatever I have already said, fourth bit to 0. Fourth means this is first, second, third, fourth. This bit position I want to make 0 without disturbing all other bits, means they will remain as it is. I should not change their values. Then we need to AND all other bits with what? 1. That I already said. And fourth bit with 0. Why? Because something and 1 will remain something, and something and 0 will make it 0, right? So due to this logic, we can do that. So let's see how it is happening. These are my original bit values that I am ending with 1. Fourth position as 0 and all other positions as 1, 1. So fourth position as 0, all others as 1, 1. What will be the result? This particular row only. This particular row only. See, this particular row only this position will be changed to 0, because that is asked to do, right? So this we have seen. So now suppose the question is, write the instruction that will reset the fourth position in a register to 0 and keeping all other bits as it is. Then your answer will be, you need to write AND. Instruction operation will be AND. And which register you need to do? R1 they have given. But with what you have done the AND operation? With this content, right? With this content. So this content, you can directly write the decimal of it, or what we will do, I will simply write the hexadecimal of it. It will become easier for me. So see, 0111 is what? 7. Hope you know these binary combinations now. And 4 all ones is what? 15. 15 in hexadecimal as said as F. F7. H I will write to indicate that it is a hexadecimal number. As well as I will write hash sign. You remember that? Hash indicates immediate operand. Because with this immediate operand, I will AND the content of R1. Then my result will become like this. So what you will be asked to do? You will be asked to do you need to write the instruction. So please remember, whenever you need to reset a bit position, then go for AND operation. Wherever you don't want to change, AND it with 1. Wherever you want to reset to 0, that position value you should AND with 0, right? So ultimately see, this one is the answer. AND has F7 H comma R1. This how also we can write our answer. Done. Next, one more I will do. Or see, or we are going to use whenever we want to set some particular bit position. Means I want to make it 1. One particular position I want to make it 1. But remaining all other bits, whatever they were there, should be like that only. That time we can use OR instruction. You see. So see, is used to set some specific bit position, keeping all other bits intact. See, here I have written register. Wherever you want to do with that content, you do the OR operation. So it is not that only in a register, because mostly with immediate operand we write register, because of that it is written like this. So R1 content is given. Then let's say you want to change the third position. This position value you want to make it 1. Then what you have to do? You have to OR that position with 1, all other positions with 0, because something or 0 will be what? Something. See how? 1 or 0 will be what? 1. Answer is 1. 0 or 0 will be what? Obviously 0. That means whatever is this value is coming as my answer. So I should OR with what? 0. This is understood. Second one is something or 1. Then the answer will be 1, because that OR is Whatever, if any one of them is 1, result is coming as 1, so it is 1. So see, this already we have understood. Now we'll do it. Register content is given to me like this. Then I will do what? OR operation. With what? This position as 1, all other as 0, 0. Then the result will be what? Whatever is there on the top. This part, whatever result is there, that will be coming. So this is coming. Only this position is set to 1. Set to 1. Now, if I need to write the instruction, what it will be? OR. With what I have done the OR? With this content. This content is representing what? 4. You know that hexadecimal 4 binary bits are grouped together, and then we write the decimal for that. That is 4. And all zeros is what? Very simple, 0. Hexadecimal, so H. Immediate operand, so hash sign, comma. What is register name? R1. So this is the instruction. Hope this is clear. So again, remember, OR is used for setting, AND is used for resetting. Done? But another word of caution, whenever you are setting this, all other bits you should not change. All other bits should remain as it is. Next is JOR. JOR we can use whenever we want to clear some register content or some content we want to JOR. Then see what we know in case of JOR. 1 and 1 is what? 0. 0 and JOR 0. 0 JOR 0 is what? 0. If, what does it mean? Whenever this is similar to that of this one, then the answer is coming as 0. So if my bit value is 1010 something is there, then if I do JOR with myself, I'll get all the position bit values as same as of my first input. So all the bit values will become what? 0. After doing what? JOR operation. So we will use JOR operation whenever we want to clear some content, right? So see, is used to clear the contents of a register. R1 is like this. I want to make it 0. Then X, and see why it is like this. X JOR X. Something JOR with something will be what? 0. Because that something is there in both the sides. Both is same. So some similar things JOR you will do. That means result will be 0. So R1, again with R1 I will do JOR. Result will be what? All the bits will be 0, 0. So result is 0, 0. Now what to write as the instruction? JOR R1, comma R1. Done? See, here there is no immediate operand. I am doing it with myself. Who am I? I am register R1, right? So what is the impact? Impact is the register content is register content is cleared to 0. All the bits, not a particular bit. All the bits are set cleared to 0. And in case of AND, a particular position is reset to 0, and in case of OR, particular position is set to 1. This basically we will do in some situations. We'll do that. Next is set C. Already you know what is carry flag. So in your flag register, one position is indicating carry flag, and when it is impacted, whenever you perform some instruction. So see, without doing something, you want to make your carry flag as 1. Then direct instruction is there, that is set C. If you execute simply set C, then whatever be the previous value, I don't know, my carry flag value, whatever position is indicated by carry flag, that value will become 1, right? So CF equal to 1. Otherwise, directly there is no such way is there by which you can set the value of your carry flag without executing any instruction. Then clear C. This one is again the same thing. This time we'll be making it 0. It is used to reset the carry flag. So CF equal to 0. Then next is COM-C. It is used to complement the carry. So if it was previously 1, after executing this instruction, this value will be 0, right? So basically, actually, when we use this, whenever we do some internal operations and the value of carry is 0, indicates a successful condition. So before doing my operation, I will execute set C. That means initially I will be in a fault position. Then I'll do the operation. If the operation is successful, then your carry flag will be your 0. Automatically it will be set to 0 by the operation. The way you do that in your Unix and all, that make directory, change directory, whenever we execute those commands, whatever we do, if the operation is successful, carry flag is set to 0, right? So initially I will be in a fault position. If my operation is successful, carry flag will